Hi everyone. In this video, you will learn how to estimate limits using graphs. Let us jump right into an exercise. What is the limit of the following function at x equal to -2? What about at x equal to 3? If you would like to try this exercise on your own first, you can download these notes using the link in the video description. To find the limit of this function, as x approaches -2, means to find one value to which the outputs of this function get closer and closer to as the inputs approach -2. Let's first find the input of -2 on the x-axis. There are two major ways in which you can approach -2. You can approach it from the left or from the right. Let us first use inputs that approach -2 from the left. For example, the input of -4, -3, -2.5, and -2.1. These inputs have corresponding points on the graph of the function. For example, the input of -4 has the corresponding pink dot on the graph of the function. The input -3 has the corresponding pink dot on the graph of the function. So I add the remaining two pink dots. Those points on the graph of the function have some y coordinates. The first pink dot I drew has the y coordinate of -3. The second one appears to have the coordinate of -2. Third one may be -1.7. The next one, -1.2. Now, as the inputs approach -2 from the left, the outputs of the function appear to approach -1. Instead of drawing points, mathematicians often draw arrows. So, instead of denoting inputs by green dots, I will denote the inputs that approach -2 from the left by an arrow on the x-axis. To denote the points on the graph, I will draw a pink arrow on the function. Now, this pink arrow points toward a point with a y value of -1, which suggests that the limit of this function could be -1. Let's do the same thing with inputs approaching -2 from the right. I will draw an arrow pointing towards -2 from the right, and then I will draw a corresponding arrow on the graph of the function. That arrow also points at a point with the y value of -1. So as the inputs approach -2 from the right, the values of the function also get closer and closer to -1. So this suggests that the limit of this function as x approaches -2 is -1. Let's do the same thing at the input of 3. I find x equal to 3 on the x-axis, and I will approach it first by using inputs on the left side of 3. I will then draw the corresponding arrow on the graph of the function. That arrow points toward a point with a y value of 2, with a y coordinate of 2. Now I do the same thing from the right. I draw the arrow on the right side of 3, and then I draw the corresponding arrow on the graph of the function. That arrow points toward a point with the y coordinate of 2. From the left, I get closer and closer to 2. From the right, I get closer and closer to 2. So, the limit of this function is 2. You may be worried that in this second case, the dot was open, it was not filled in, while in the first case, the dot was closed, it was filled in. An open dot means that the function is not defined at x equal to 3. This function does not have a value at that input. However, limits do not care exactly what happens at that exact 3. What limits tell you is how the outputs behave near 3. The limit will tell you what happens to the values of the function as x's approach to. The limit doesn't actually tell you what happens exactly at 3. It only tells you what happens near 3. And it is indeed true that as the inputs of the function get closer and closer to 3, the outputs of the function get closer and closer to 2. The fact that the values of the function actually never get there is irrelevant. Let's try a problem that asks us to find the limits of the function below by using the graph. If you would like to try this problem on your own first, this will be a good time to stop the video. To find the limit of this function as x approaches -4, I find x equal to -4 on the x-axis. Then I will approach it with the inputs from the left and from the right. I will draw the corresponding arrows on the graph of the function. Those arrows point towards a point with the y-coordinate of -2, which suggests that the limit of this function as x approaches -4 is -2. I do the same thing with the next limit. I find x equal to -2 on the x-axis. I approach it with inputs by going to -2 from the left and from the right. I draw the corresponding arrows on the graph of the function. Those arrows point toward a point with the y-coordinate of 2. So the limit of this function as x approaches -2 is 2. Note that the fact that the value of this function at -2 was 3 is irrelevant. It doesn't matter what the value of the function at -2 is. What matters is what happens to the values of the function as x's approach -2. And those values definitely get closer and closer to 2. Let's find the limit as x approaches 0. I find x equal to 0 on the x-axis. Then I approach it with inputs from the left and from the right. I draw the corresponding arrows on the graph of my function. From the left, the arrow points toward a point with the y-coordinate of 1. From the right, the arrow points toward a point with the y-coordinate of -2. These are two different numbers. In that case, we say that the limit does not exist. Remember, the limit of a function at a particular point can be only one number. It cannot be two numbers. It's just one value. Let's take a look at the limit as x approaches 2. I find x equal to 2 on the x-axis. I approach it from the left and from the right using my inputs. Then I draw corresponding arrows on the graph of the function. Those arrows point toward a point with the y-coordinate of 0. So this limit is 0. Finally, we must find the limit as x approaches 4. I find x equal to 4 on the x-axis. I approach it from the left and from the right using the inputs. Then I draw the corresponding arrows on the graph of the function. And those arrows point toward a point with the y-coordinate of 1. We say that the limit as x approaches 4 is 1. Again, it did not matter that the function was not defined at x equal to 4, because the limits don't actually care what happens exactly at 4, but only as you approach 4.